Hi everyone, my name is Miroslav Šedivý and I would like Python to get me home as quickly as possible. Cities are one of the greatest inventions of the humanity. Imagine thousands of people living not far away from each other and improving their economy, politics and culture. But getting around the city is not very simple because usually you have several ways on how to get from A to B. And getting around the city doesn't look much like this. It looks more like this. So if you use mass transit or a car, you just get into the queue with other people traveling on the same mean of transport and then waiting and moving at the same speed. But there are some other individual means of transport, for example walking or cycling, that are really very individual because everyone rides at a different speed. And everyone has a different way of accelerating braking. Everyone behaves differently in front of different obstacles. And for example, on such a bike track, would you go near the cars when any time a door may open, or would you take a different road? And here, will the door open or not? So what I wanted to know is how fast can I get from A to B? I took some random app with real-time online navigator for my cell phone, and then I told him, okay, I want to go from the castle in the center of the city to some place in the suburbs. And this app told me, okay, you can take, for example, you can take here one of the busiest roads in the city, or would you like to go directly through the zoological garden where you are not allowed to take a bicycle anyway? So I took a look at another app and it proposed me a different route. And I thought to myself, hey, which one is the fastest one to get from A to B? So exactly as the second app proposed, I just took this route and I measured it, tracked GPS, and I saw that there are some places where I had to stop because there were some lights, and maybe there is another possibility how to get from A to B. So what I did, I took several roads from A to B and different ones, and also I tried to not only to go from A to B, but just from C to D and from home to work, from some other places. And then I recorded all of them. And I tried to find some rules or some way to identify which is the best way to get from A to B. And then I did plenty of trips, and just for this presentation I just choose 3 of them, and I loaded them into JSON and then tried to find all the intersections and all the points of interest. So for example, we have here a crossroad where there are some trips going from between different points, and then not automatically but manually I found the points of intersections. And then I defined a new network with paths between these spots, and then I saw that, okay, there are also some crossroads that are not only simple crossroads where you can turn left, right, go straight ahead at any time. There are also some crossroads with traffic lights where you are not allowed to turn left, where turning right is much faster than going straight ahead. And this way I built a whole network. There is a project in Python because I wanted to write a real project in Python on GitHub, which is called PyGoHome, using a few third-party libraries for geographical and mathematical computing. And IP-Layflat and IP-Widgets are libraries for Jupyter Notebook representation, interactive work with the data on a map. And then I took all my trips and then tried to find all the intersections and manually enter them to the GPX files. At the end, I had a network of all the intersections and all the routes. These are not based on the map, so it doesn't use any map information. It uses only the data from my GPS tracker. And then, for example, here to get from A to I, there is one route, there is another possible route, and there was a third route. But you see that, for example, between A and B, I have already two data. And this is exactly what makes it individual, because if I go right on a segment between two intersections, it depends on my speed, on my acceleration, braking, on my behavior in front of obstacles, on the current weather, on the current traffic, current route condition. That when I take some segment several times or many times, I will get a lot of data, a lot of time data, like this time number of seconds passed between points and AB, and I will get some mathematical distribution or mathematical representation of how fast can I get from A to B, and then composing it to a bigger network, how to get between any 2 points. Because then I could take a trip, for example, from G to C, and then you see that probably the fastest route may be A, B, E, F, I, although I have never taken exactly this route. So this is method and distance that I'm combining using much more data that I would have only if traveling between A and B. Then with this data, I could build some statistical representation. So, for example, if I have a segment that goes through the city and there is traffic light, so it can take somewhere between 4 and 8 minutes depending on the traffic light. And there is another way around through a park, which is in the average is a little bit slower, but there are no lights, so actually I will always need around 6-7 minutes. And in this case, if I statistically try to find the best route, I can say, oh, I am feeling lucky, so it's Sunday morning, nice weather, nobody is there, so I will be actually, in average, will be faster than the average. In this case, the route through the city will be faster. But if I want to make sure and I want to get somewhere and make sure that I won't need more than a certain amount of time, I will try to see in the upper limits of the distribution. And in this case, I see that going around through the park is actually faster than going through the city. So this is how it looks like. You can go to PyGo Home, download it, try it with your own data, or there is a MyBinder link button where you can click and it will load, and then you can upload your GPX data and test them. And then choose some 2 points in your surroundings, and in the quantile you ask 0 is the fastest, 1 is the slowest, the safest one, and then it will tell you how much time you need it. So for example, in this case, between the castle and the park, I needed 9 minutes and 11 seconds in the fastest case, but the slowest with all the lights and traffic and everything took me 22 minutes. On the other hand, if I ask for the safest route, it will give me this one, because the fastest time was actually 11:43, which is a little bit more, but I was never slower than 13 minutes and 18 seconds. There are plenty of things that I would like to work on PyGo Home. I would be happy to hear your feedback. So there is something like isochron map. I have a point and I want to know in which area I can get within 5, 10 or 15 minutes. It should automatically detect the GPS problems, detect brakes and vehicle swaps. So for example, if I just get off the bicycle and push for a while, detect and edit intersections automatically, because now I do it everything manually. Maybe some machine learning depending on which weekday or daytime is it. Integrate with OpenStreetMap with the data from the map. Avoid and prefer tracks, and maybe do it everything in PostgreSQL without using Python at all, and maybe an app or some more platforms. I would like to hear from you. Thank you very much.